Excellent. This is Antiquated Perl. So, people sort of talk about modern Perl, and then you have the whole, Larry called Perl a postmodern language. So maybe there's postmodern Perl. And then, as I hope those of you who were in here before will now know, there is been a movement coming for the past few years called Enlightened Perl, which now has a non-profit organisation to support it. And okay, I guess everybody already knows that the Enlightened Perl movement is built around things like Catalyst and DBIX Class and Moose, and I guess you all know I'm involved with those, but I mean, what is modern Perl? It means it's new, it's what's happening today maybe, but so Perl 5 version 10, we've now seen 10.1, which is the first full production release of the version 10 series. Provides things like the wonderful give and when construct and the smart match operator, but so what's the opposite of modern Perl? Well, I guess you could say it's old Perl, but old is, well, old code. If it works, that's great, but other than that, it's not that exciting. Legacy Perl? Well, I could do an entire talk swearing about formail.pa, but that's probably not that interesting. If anybody wants to hear me swear about formail.pa, buy me a beer later. So what I thought I'd talk about instead is Antiquated Perl. So I guess first we have to ask, what do I mean by that? Well, antique. Antique doesn't just mean old. It means old and beautiful and things that have stood the test of time. Simple things, elegant things that let you do lots of clever stuff. And Perl is full of things like that, and we don't know about most of them. I mean, one of the simplest ones is the $pipe ++ idiom, which is to turn auto flush on. Now, yes, you can load IO handle and call it as a method, and that's really nice, but IO handle has been part of core for years, so you don't even need a module for it. But why think about it when you already know that setting $pipe to 1 does the job? And there's all sorts of beautiful tricks around it, like this one, which is to set auto flush on a particular file handle. What happens is you do select $foo, you select foo, which selects that file handle and returns the old one. $pipe gets set, so auto flush gets set on the file handle you just selected. And then, because you take the first element of the array, you get the old file handle, which means that the select foo idiom selects the foo file handle, sets it to auto flush, and then puts your default file handle back to it normally was. Now, okay, it's actually much prettier and cleaner just to load IO handle in that case and call auto flush straight on foo. But I think it's an example of one of the neat little tricks that we've had down the years. And people go, tilde, the Perl 510 smart match operator. Well, tilde actually means something in old Perl. You can do tilde at x. And the funny thing about that is, what it does is it means tilde of at x. Unary tilde put together twice. Now tilde is bitwise negation. So what that means is, now, it's bitwise negation, so it's a scalar operator. So it forces the right-hand side into scalar context.
Oh, yuck.
Now, if you negate a number twice, you just get the number, which means that tilde is actually a short form for scalar. And that's useful sometimes in one-liners. As we have this lovely example that demonstrates why I'm not going to be using Moose as part of this talk, much though I love it. But there's all sorts of fascinating things. Overload constant. You barely ever see it anymore. I mean, people use operator overloading, but overload constant lets you change the way Perl parses constants. It's built in, no C code required. You can affect how numbers and strings are parsed. You can parse all of those different types of strings with it. So as an example, Audrey Tang wrote this fantastic module called I18n.pa, So you use I18M, and it grabs all of the strings that get made in the process of your module, and that means that you can do tilde tilde, because it overloads the tilde operator, to get a much nicer syntax for localization, where you can use your variable names, and then that compiles down to a lookup into your lexicon of phrases. And the humble for keyword. People, okay, for each loops we all know that, but for has this wonderful property because it aliases to $_. So if you don't have things like given and when, you can do for $foo, that puts it in $_, and now you can do things that expect $_. It effectively works as a with keyword for Perl, except built in, and it's always been there. So you can build up switch statement style things by doing a test on $foo and then using a do block to return some sort of value. And then there's the interesting thing. I guess you all know about the G modifier on regex, but C says don't reset the match position even if this is a different regular expression, which means you can then use a different regex, and instead of matching the start of the string, you use the \G marker, and that says carry on from where the other regular expression matched. And if you've got that, you can build parsers with it. So you say, if it matches this, do a subparse. Inside the subparse routine, you do for, and you use the element of @_ directly. Remember, @_ is aliases, not copies. So it's the actual same scalar value, the same C scalar value under the hood. Which means when we do the submatch in the parser, it's matching from the position where the outer parser left off. And once you add in the built-in pos that allows you to get and set the position, you can actually do backtracking regular expression parsers with this, which has some interesting possibilities. And subroutine prototypes. People go, oh, prototypes are a bad idea. I mean, mostly they are. About the only time you really want to use them is for the ampersand prototype, which allows you to make built-in style things. So you declare a sub as ampersand, and then it takes a block, which is how, for example, error.pm creates its try-catch stuff. These days I would suggest using try::tiny for lightweight stuff, and the double declare based try-catch module when you're doing complicated stuff. But the principle is quite interesting. And the other interesting thing is there's a built-in function called prototype. Nobody really pays much attention to it because it's not normally that useful, but it lets you get the prototype string for a subroutine so you can introspect it, see if it's been declared specially and how its arguments work. Which, by a slightly odd route, brings me to the humble type glob, the core of Perl. A symbol table, a package, is just a hash of type globs, and you can do things with that. So your way of building an exporter without using exporter.pm is that if you turn strict refs off, which I recommend you do only in the block you're using it, then you can actually install a method into a package by referencing the package name type glob, and doing equals sub sets the code slot of the type glob, which is exactly the same as a normal subroutine declaration does. But the really interesting thing about it, so, I'm sorry, this is a different part. So, local. People forget about local. Oh, you should be using my for everything. But local has the interesting thing that it's dynamically scoped. It's scoped to the call stack. So if you do a local here and call something else, the local is still in scope over there, which lets you do some fairly interesting things. Local $_, useful piece of defensive programming. More interestingly, you say, well, I've been using croak in my code, but I need a verbose error in this bit. So you say local star carp croak is carp confess. And then anywhere inside there, where you call croak, it does a confess instead, and you get a full stack trace. So you can use that to turn stack traces on selectively just for the piece of code that you're trying to debug. So you don't take the overhead of generating the stack trace, and you don't get big error messages, except in the part of your code where there's the bug, which is what you're trying to look into. And another thing you can do with local, this is a beautiful trick. Setting local at argv and $/. Because you provided no value for $/, it becomes undef, which means slurp the entire file at once. By setting at argv to $file, you can use the built-in one-liner trick of empty file read, and that will read from the file. The really nice thing about this is, because Perl is clever, when it's going through at argv, if it gets an error opening a file, it throws it for you. So you don't actually need to put the or die in, and that's actually still safe code to slurp from a file. It can be very useful sometimes. Another thing, strict and warnings. We all know about strict and warnings, of course. But the way they're implemented is quite interesting. Strict arrow import actually sets a bunch of hint bits in a compiler internal variable that the Perl compiler uses to work out what it's doing. So it affects the current compilation scope. It doesn't actually affect anything at runtime. And warnings does the same thing for a special value called warning bits. Which means you can, if you want, fiddle with those directly to turn strict and warnings on, but I would not recommend it. But the interesting thing about that is, because it's affecting the compilation scope, you don't have to worry about the caller or anything. The thing that matters is what the compiler's doing. So if you call strict import in another import routine, it affects the thing that's being compiled. So if you write a subroutine like this, that's the strict and warnings packages import method, that calls strict import and warnings import, then you can do use strict and warnings in your code, and that turns strict and warnings on for you. This is how Moose does it, by the way. And you can use it for your own, even if you're not using Moose. If you have something that you use a lot in your applications, you can have that package turn them on for you so you don't have to type it out every time. Which I find very useful because I often want fatal warnings. Because I'd much rather the thing just died at the point at which I've done something stupid than printed to standard error and carried on. Getting a bit further into the compiler, there's two sorts of hints. There is $#h, which is a scalar, which is basically a big bit field that's tested from the C code, and %h, which is a hash of information, which is used to store various context data that Perl needs. So you can do this interesting thing. If you add a magic set of bits to $#h, it localizes the hash, localizes it to the compilation scope. So that copy of %h now is going to go away when Perl hits the closing brace for the block that you're compiling, which means if you add a destructor to that, at the end of your compilation scope, %h goes back, the object you put in it goes away, and your destructor's called. Which means you can do cleanup. Rather than having to do use my module, code, know my module, you can just have use my module and use this, and at the end of that block, the destructor can automatically unimport and clean up for you. Which means when you're fiddling around importing subroutines to make things easier, you can keep them scoped to a particular area so they don't affect the rest of the file, which allows you to write much more careful code. It allows you to scope your imports just like mine lets you scope your variables, which is, I always think is a very good thing because I like using a lot of things that change the way Perl behaves, and I want it to only happen for the piece of code I used it in, and not affect anything outside of it. And the way you do it, because the package is just a hash of type globs, you just delete the hash entry. And that gets rid of the import that you put into scope. There is also bhooks end of scope, which does it a slightly more clever way using some C code. And bhooks end of scope allows you to get around. There are certain issues if you do a string eval within a block, %h propagates. So if if you've got a compiler handy, bhook's end of scope is the safe way to do this. We've gone through about 4 designs